All right, 3.1 practice. All right, so what we're doing here is we're going to use the vertical line test to check and see if this is a function or not. So when I go down and drop a vertical line, I only hit one time. So yes, this is a function. Okay, my domain, remember that means left to right. So how far left does it go? And how far right does it go? So it goes from -4 to +4. And since they're solid dots, we're going to use brackets. Now the range, remember the range is up and down. So how low does it go? And how high does it go? In this case, it's not too interesting because it goes from -4 to +4 also. All right, for this one, when we drop the vertical line, we hit more than one time. And so therefore, it fails the vertical line test, and we're not going to worry about the domain and range here. All right, number 3, same thing. We only hit one time every time, so yes, it is a function. Now, how far left does it go? Well, we see it goes from -5 to the right, +5. So -5 left, 5 right, both brackets because they're both solid dots. Now, if this would have had an open dot, this would have been in parentheses. All right, now how low and how high does it go? Well, the low is 1 and the high is 3. So it goes from 1 to 3, both inclusive. All right, so I'm going to start actually by writing the domain first. The domain, when you have a list of numbers, is just writing down the x values. So we have, I'm going to put them in order, -2, 2, and then 4, and then 6. Okay, and the range, I'll do those in order, -5, 1, and 3, and we have 3 twice. All right, so yes, this is a function. If you wanted to plot this, that's fine, okay, but it's okay for the y's to repeat. If you think about this, 2, 3, and 6, 3, 2, 3 would be here and 6, 3 would be here. That does not fail the vertical line test. So it's okay for these to repeat. All right, what do we have here? In order, we have -4, 0, 6, and 8. And in order here, we have -7, 1, 1, and 2. Again, you don't have to repeat those, but it's okay if you do. And since the y's repeat, that's okay. Now in this one, on the x's, we're going to have a no. And you can see that because we have 2 4s. So from x's, I have -5, 0, 4, 4. That's a big no-no. All right, my range, I have -2, 1, 3, and 3. That's okay, but it's just the 2 4s here that make this a no. Because if you think about it real quickly, 4, 3 would be up here, 4, -2 would be down here. That would fail the vertical line test. All right, number 7. Okay, 5 only gives us 2. 3 only gives us 2. -1 only gives me -7. There's no repeats, so that's a yes. My domain is just a -1, 3, and 5. My domain is just my y values. I'm sorry, my range is just my y values, which is -7 and 2. All right, now number 8, 6 gives us 0, But negative 1 can give us 4, but it can also give us negative 8. That's a no-no. Okay? And the domain here is 6 and negative 1. We don't have to list this if it's no, but just for practice, negative 8, 0, and 4. All right, number 9. There are no repeats. The domain is negative 3, negative 2, 0, 1, 4. Okay, so remember, my domain is my x values, my range is my y values. The little way to remember that is domain D comes before R, X comes before Y. All right? And range is negative 5, negative 2, negative 1, 1, and 2. You don't have to put them in numerical order. It's just whatever you want. You could have written them just like this. All right? But that's the range. There's no repeats in either, so it's a yes. Again, repeats in Y wouldn't matter, but there's no repeats at all, so that you don't have to think about it. Number 10, the domain. We have 2 repeating x's, so that's a no. Okay? And I'm not going to bother writing them again. I think you know what's going on. All right, so notice up here we have f of x, g of x, and h of x. So you have to pay attention to what you're doing. So g of negative 2 means I'm going to plug a negative 2 into this right here, because that's g of x. So I'm going to do negative 2, replaces the x, plus 4. So negative 2 cubed is negative 8. And that gives me negative 4 for an answer. Now f of 4 means I'm going to plug it in here to f. Negative 2, replace the x with the 4, minus 5. Negative 8 minus 5, which is negative 13. H of 5, plugging it in here. So I'm going to replace every x. So 5 squared minus 3 times 5 plus 1. So that's 25 minus 15 plus 1, 10 plus 1, 11. Now this one throws people off because we have another variable being plugged in for the variable. That's okay. We're going to plug it into f. We're going to plug it in right here. So we're going to take the x out and replace it with 3a. I know it seems weird, but that's okay. Minus 5. So that's going to give me 6a minus 5, and I stop right here. I cannot go any further. I cannot say this is 1a. They're not like terms. We stop. And my only mistake is that was supposed to be a negative, and so I'm going to put a negative 6a. I just caught that right there. All right. This one, we're going to plug 2b into h. So everywhere there's an x, we're going to replace it with a 2b. In parentheses, minus 3, again, 2b, we're replacing the x with a 2b, plus 1. So 2b squared is going to be 4b squared, minus 6b, plus 1. Now we stop. That's as far as we can go. Negative 2c, we're going to plug that in right here. So we're going to take the x out, that's being cubed, and replace it with negative 2c. Plus 4. Now negative 2 cubed is negative 8. C cubed is just c cubed. And then plus 4. And that's as far as we can go. All right. Identify the type of function and then state the domain and the range. Okay. So this would be a good thing to use the worksheet for in the notes. Okay. So this is a straight line, which means it's a linear function. Okay. Now, in Algebra 1, since it's going left and right forever, up and down forever, you would have just said all real numbers. But in Algebra 2, we're going to say negative infinity to positive infinity. And that's the same for the range. Because it's going left and right forever, because it's going to keep going left, it's going to keep going right, and therefore it's also going to keep going down and keep going up. All right. Now this sideways one, anytime you see this little snake, you know it's a cube or cube root. Okay, if it's going left to right or east to west, it's a cube root or cubic root. Okay, it is going left and right forever, so negative infinity to positive infinity, and is going down and up forever, so again, negative infinity to positive infinity. Whenever you see the V, that's V for value. Absolute value. Now, this one is going to keep going left and right forever, so negative infinity to positive infinity. But how low does it go? Well, it hits here at 0 and bounces back up. So it only goes down to 0, and we're going to use a bracket for that because it hits 0. And then it goes up forever. Right? Number 20 is exponential. We're going to be more specific and call it exponential decay, because over time it's going down. I mean, it's going up too, but if we think about time in an orderly left to right fashion, it's going down. It's decaying as time goes on. All right? So how far left is it going? Well, it's going left forever. How far right is it going? Forever. Now, how low is it going? Well, it's never going to hit 0. Even though it looks like it will, it never will hit 0. So we're going to put 0, but we're going to put parentheses. And then, how far up does it go? It goes up forever. Now, in Algebra 1, you would have said this was y is greater than 0. But we're doing it a little bit differently now in Algebra 2. All right, this one is a parabola, which means it's a quadratic. We can just abbreviate there. How far left does it go? It's going to keep going left forever and right forever. So negative infinity to positive infinity. How low does it go? Well, it hits 0, just like the absolute value. And it's going to be a bracket. And it goes on forever up towards infinity. 22. This one is a square root function. All right. How far left does it go? Well, you can see the borderline is at 0. And it touches 0, so we use that. How far right? Forever. Okay. How low does it go? Again, also, it bottoms out, starts right there at 0. Okay, because we can't take the square root of a negative number. So that's going to be 0. And how high does it go? Positive infinity. Now this one is exponential also, but as we go over through time, it's going up, so it's exponential growth. The domain is going to keep going left and right, and the range is going to keep going left and right. Sorry, my bad. I don't know what I was thinking, kind of blanked out there for a little bit. How low does it go? It's going to be never hitting 0, just like before with the decay. And it's going to be going up forever. And the last one is a cubic function. Okay, it's that snake again, but it's going north-south, up and down. So this one is pretty easy. It's going left and right forever. And it's going left and right, I'm sorry, my bad, up and down forever. And that's 3.1.